Hi students, in this video we are going to discuss about classification of magnetic materials. Okay, so we already discussed about all the magnetic properties of a magnet. Okay, in our lower classes we studied about only three magnetic materials, that is diamagnetic material, paramagnetic material, ferromagnetic material. Okay, and now additionally in our higher studies we are going to study about anti-ferromagnetic material and ferrimagnetic materials also. Okay, so the following are the magnetic materials are of five types. They are diamagnetic material, paramagnetic material, ferromagnetic material, anti-ferromagnetic material and ferrimagnetic material. And next let us see one by one. Start with the diamagnetic material. An electron moving around the nucleus results magnetic moment. We know that very well. Due to different orientations of various orbits of an atom, the net magnetic moment is zero, because when a magnetic field is applied, all the magnetic moments of its atoms will align in the opposite direction of the applied field. In diamagnetic materials only, there is complete repulsive. Whenever we are applying the field, all the magnetic moments which are present in atoms will align in the opposite direction of the field, like this. So we are applying the field H in forward directions, and all that magnetic moment of atoms are set into the opposite direction of the field. So the relative permeability mu r, that is less than 1, and susceptibility psi, that is negative. Psi is independent of temperature. So example for diamagnetic material is organic materials. Okay, and next paramagnetic material. Let us see what is a paramagnetic material. Each electron in an orbit has an orbit and orbital magnetic moment and spin magnetic moment that it has. Due to electron we are getting a magnetic moment and spin magnetic moment, orbital magnetic moment and spin magnetic moment. When shells are unfilled, there is no magnetic moment. In the absence of external magnetic field, the net magnetic moments of the atoms are arranged in random directions because of the thermal fluctuations. Hence, there is no magnetization condition. When external magnetic field is applied, all the magnetic moments align into the direction of the magnetic field. So the induced magnetism is the source of paramagnetism. That is, when we are applying the field in forward directions, all the moments are set into the field directions. When we are applying backward directions, the field and the magnetic moments are also along with the field directions. Okay, see here. So when there is no field, all the magnetic moments are in a random direction. Whenever we are applying the field, those are aligned in a field direction. Okay, and next here the relative permeability. The relative permeability mu r, that is greater than 1, and the susceptibility psi, that is low and positive, that is give psi equals to c by t, where c is a q is constant. Example, alkali metals and transition metals, those are examples for paramagnetic materials. Okay, and next let us see ferromagnetism. What is the ferromagnetism and what are the ferromagnetic material properties? In ferromagnetic substances, the permanent magnetic moment is mainly due to the spin magnetic moment, which will be aligned parallel to each other. In the absence of external field, they exhibit magnetization. I am repeating it again. In the absence of external field, they exhibit magnetization. This is due to the spontaneous magnetization. There is a special form of interaction called exchange coupling, so occurring between adjacent atoms, coupling their magnetic moments. So the coupling occurs between the adjacent magnetic moments. Okay, see here, non-magnetic material, there is no domains. It is a magnetic material, so domains but not lined up. But when it is a complete magnet, domains and all are lined up. Okay, so relative permeability mu r, that is very much greater than 1. Susceptibility xi is high and positive. Example, transition and parallel earth metals. In xi equals to C by T minus Tc, where Tc is the Curie temperature. As we already studied in our previous class, there is a Curie temperature. Okay, see how the susceptibility will vary along with the Curie temperature. Okay, next, anti-ferromagnetic materials. The materials with anti-parallel magnetic moments are known as anti-ferromagnetic materials, and their magnetic moments are shown in figure. See how they will be. The materials with anti-parallel magnetic moments, okay, those are known as anti-ferromagnetic materials. Now the net magnetic moment exists in the direction of applied magnetic field. So the relative permeability mu r, that is greater than 1. Susceptibility xi is low and positive, and xi that equals to C by T plus Tc. The temperature is added to the Curie's temperature. Okay, so for this only, the basic definitions in dielectrics and magnetic materials is very important. Whenever we are remembering all those permittivity, permeability, susceptibility, all those conditions, then only we can understand this concept very easily. And next, ferromagnetic materials. Can you observe the difference between the anti-ferromagnetic materials and ferromagnetic materials? See, the substances which consist of anti-parallel magnetic moments of different magnitudes are known as ferromagnetic substance. Here, those are also aligned in anti-parallel, but the magnitudes are same. In case of ferromagnetic materials, even though those are anti-parallel magnetic moments of different magnitudes, that is known as ferromagnetic substances. Relative permeability mu r, that is very much greater than 1. Susceptibility xi is high and positive. Example, ferrites. So xi equals to C by T plus or minus Tc. So that will be added or subtracted the Curie's temperature. It depends upon the magnitude. Okay, and next, let us see what is the Weis theory of ferromagnetism.